All right, so as we approach our first semester midterm here, I've picked out a few topics that I think are kind of the more high level topics. Certainly, this is not going to cover everything that you're going to see on the exam, but again, I think these are sort of the more high level, maybe somewhat difficult to understand topics. So, right off the bat, you can see we're going to talk about metric conversion. I think that one is pretty straightforward, but pretty important. Ohm's law, similar, obviously very important. Varying voltages, I'll explain what that is. You guys have seen this quite a bit, and it's not going away. Box fill seems to be one of the more difficult to understand topics in our curriculum for whatever reason, and there's a lot of moving parts to that. And then we have receptacle spacing. So those are sort of the five big topics I want to cover here. And I think if we can understand these, you're going to understand a big chunk of what's on the exam. So jumping right in here to the metric conversion, that I think we can keep pretty straightforward. I really only need you guys to remember three units in this metric conversion, and that's the kilo to base to milli. We need to be able to fluidly convert from any one of these three to any of the other three, right? So for instance, to give you an example of what we're talking about, if I said 13.2 kilovolts, that is the same as 13,200 volts, or in this case, what, 13,200,000 millivolts. And to put it simply, the trick to this is each one of these, we're going to move the decimal point three places, either left or right. So if I start at 13,200 volts and I say, how do I turn that into kilovolts? I'm going to move my decimal point three places to the left. So right now it would be right here. I'm going to go 1, 2, 3 places to the left. I would place the decimal there. That's how we get to this. Same question if I said I need to go from 13,200 volts to millivolts. I'm going to move my decimal three places to the right in this case, or in this instance, we are here, right? We're going to move it 1, 2, 3 places to the right to give us 13,200,000. And then if we were to go from millivolts to kilovolts, I would go 1, 2, 3, 4, 5, 6 places to the left to get all the way over to here, right? So again, in a nutshell, we're just moving that decimal three places left or right. And those are the only three values that I'm holding you guys responsible for. I know the text had a bunch of other values in there. Hecto and mega and all that kind of stuff. But for our purposes, for the career as an electrician, those are the big three you really need to know and be familiar with. And that is important because you're going to see a lot of problems, even on this test, where they throw one out there in kilovolts. But we need to do all of our calculations using the base unit, right? Amps, volts, watts, and ohms. We can't use megawatts to do a calculation, or kilowatts as a better example. We need to be able to convert that to its base unit easily and quickly, right? So your metric conversion, hopefully short and sweet, nice and easy. Ohm's law. This is a big one. You must be familiar and competent with Ohm's law. There's no way around it, because even in the next category here, varying voltages, we're going to need to use Ohm's law very effectively, very efficiently. So I went ahead and found an Ohm's law wheel for us to take a look at. But as a quick reminder, hopefully this sounds very familiar. We can find any value in an electrical circuit if we know two values to begin with. So you'll notice, in this case, they give us volts and they're giving us watts. So at 120 volts and 65 watts, how many amps is this thing going to draw? Say it's a light bulb. Doesn't matter what it is, right? So we're going to say, okay, well, we know volts right here. We know watts. We're looking for amps. So the first thing you're going to do, the value we don't know, the unknown value, we're going to find that quadrant of the Ohm's law wheel. In this case, amps is the I quadrant right here. Okay, so then what two values do we know? We know volts and we know watts. So let's find the formula that contains volts and watts here. That would be P divided by E. So I can come in here and I can say P, which is my watts or my power, right? 65 divided by E, which is my volts, or 120, is going to be 0.5417 amps, right? So there's my answer. Simple as that. Again, we look at, first of all, we need to make sure we know two values. And for the test, they're always going to give you the two values. But we look at the value that we don't know, the unknown value. We find that quadrant in the Ohm's law wheel. Then we find the formula that contains the two values that we do know. We're going to use that formula to find the unknown value, right? So building on that, this varying voltages idea. Again, I've pulled the Ohm's law wheel. What I mean by varying voltages, and you've seen many of these kinds of problems, what do we do if they say, hey, this equipment's rated at X volts and it's going to produce Y watts, but we're going to operate it at a different voltage than what it's rated at. Now how many watts is it going to put out, or how many amps is it going to put out? And the trick to that, you've heard me say it if you've watched the other videos. Hopefully you have. If you haven't, man, you really ought to back up and do that. But the trick to that is, you've heard me say this term many times, you need to find fixed resistance. We've got to find the resistance before we can move on. And let me explain that. In this case, we have a piece of equipment that's rated, if we operate it at 220 volts, it'll output 2,000 watts or produce 2,000 watts of power. But we're going to operate it at 208 volts instead. And this is not uncommon. A lot of equipment's rated at 220. And the reason it is so we can run it on a 208 volt circuit, which is a common voltage system, or a 240 volt circuit, which is another common voltage system. So it's rated in between intentionally. But then the issue is it's going to produce slightly more or less watts depending on the voltage we hook it up to. And we'll explore that here in a minute. So what I'm saying is we are changing the voltage. So we're going to expect that this wattage is going to change. And we could ask the same question about the amperage. The amperage will change as well. One thing that won't change is the resistance. The resistance is a physical characteristic of this device. In this case, let's say it's a heating element. It could be a lamp filament, whatever it is. That's a physical characteristic of that device or that element or that filament. We can't change that. That is going to remain the same. So no matter what voltage we operate at, that resistance is going to be constant. So what we're going to do is we're going to use the two values that we do know already, on the rated side. So here's what it's rated, so we can use these values together. But we can't use these two values with this at all. They're going to become irrelevant once we get down here. So we're going to use these two values that we do know on the rated side to find the resistance, right? So we're looking for resistance here. We know volts and we know watts. E squared divided by P, right? So again, we're going to use the rated values. So in this case, 220 squared. And I don't quite know how to do squared on here, so we're going to do that. Is 48,400. So now 220 squared, 48,400. So that's our E squared divided by P, which is, in this case, 2,000. Okay, so our resistance is 24.2 ohms, right? So what we can do now is we can use this resistance value. It doesn't matter what voltage we run this thing at, that resistance is going to remain true. So we can use this resistance value and couple it with this voltage that we're going to run this thing at. And find, in this case, how many watts. Okay, so now we're looking for watts. We come up here to the P quadrant. We know volts and we know ohms now in this case. So now we're going to say E squared divided by R, right? So if I say our new voltage here, 208 squared. So 208 squared is 43,264. So now E squared divided by R right here, which we found R to be 24.2. So our wattage is going to be 1787.769 if we round, right? So that's our new wattage there. And let's think about this and talk about this. If I ran this thing at 220 volts, it would give me 2,000 watts. What stands to reason if I lower that voltage a little bit? What do you know? I've lowered the wattage a little bit as well. And the same is going to be true for amperage. So that's a nice little check for yourselves. If your amperage goes up, or I'm sorry, if your voltage goes up, you should expect your wattage and your amperage to go up as well. If your voltage goes down, you should expect your amperage and wattage to go down proportionately as well. So a nice little check for yourselves as you're doing these problems. But this type of problem is not going away. I will guarantee you're going to see this on the final, first semester final, the midterm, and probably the end of year final as well. And quite honestly, I'm teaching year 4 at this point, and I think they saw one of these on their final last year. So quite literally, as long as you're in the IEC, you are going to see this type of problem. So become comfortable and familiar and competent with solving this kind of problem, right? So there's your varying voltages.